questo discorso. Grazie Marco e Gabriele. Preferisco molto bene la lingua italiana, but I can't talk it. Thanks Milano Scala-ZIO Queue for this opportunity. I'm glad to be here. I'm going to talk on ZIO Queue. I can't remember the slides. Okay, I'm on M.
Okay.
I'm Wiem. I came from Tunisia. I'm a Scala developer, enthusiastic about functional programming and learning. I'm a contributor on Scalaz-ZIO and the #1 fan of John de Goes, who is the maintainer of this library. I was honored to work with him on the first implementation of ZIO Queue. Actually, the current implementation is really different now, but I'd like to share with you what I've learned from my contribution. First of all, I will introduce the ZIO library and what is effectful program and how to implement queue functions. Then we are going to cover some data structure built on ZIO, and I will talk on queue. And finally, I hope that you will enjoy this talk and you will learn about ZIO and you will start work using it and contribute on it. Who knows Scalaz-ZIO or work using it? Oh. And I hope that you will learn more about it. And as the first point, John de Goes revealed the Scala-Z8 effect system in many conferences, and he talked on how much Scala-Z8 effect is performant, and he showed some benchmarks comparing to other libraries. It sounds interesting. So, and he mentioned the motivation of having effect system in Scala-Z in his blog, and he said that having or controlling effects using purely functional approach will provide strong guarantees. Even non-functional programmers will want to switch to purely functional programming, and that's exactly what happened with me and with other contributors. And understanding this approach will change the way of thinking and how to reason about your programs. It's really interesting. So Scala-Z8 effect system was in Scala-Z library, and the last year in May, the Scala-Z8 effect system is moved to a new library called Scalaz-ZIO with 0 dependencies, which means you can include ZIO in your project very easily, and you can start enjoy its features and build asynchronous and concurrent application using purely functional approach. And ZIO provides purely functional data structures with an abstraction for the effectful program. So we need to understand what is effectful programs. It's the cause of a change outside the system of your program itself. It's an interaction with the real world, like write in a file, or read from file, or raise an error, or writing at the console, or open an HTTP connection. So it's hard to control effects. If you call effectful program, they will be executed right away. It's hard to test. That's why we need some tools to mock our effectful programs. And it's hard to reason about our program and do refactoring. But basically, a program that causes no change outside our system, it will be useless. So we need effectful program. And effectful function is the opposite of pure function. So functional programmers prefer to use pure functions to make it easier to reason about, to make it easy to test and to factor code, but programming without effects is useless. So functional programmers figure out about the solution how to use effectful program with using purely functional approach. That's why they think to have a monad that which take computation, effectful computation, and the effectful computation can be mapped to monads. This is how to have an effectful program using purely functional approach. But before we will cover the I/O of ZIO, let's understand how to implement pure functions. Here we have 3 non-pure functions. For the first one, we expect that for every value of type string, we will get a value of type int. But actually, when we call parseInt with hello, it will raise an error. So parseInt is lying. It will not return an int. So this function is not total. And for the second function, add1, when we call add1 with the same input, we will not get always the same result. So we cannot test this function. So for example, if we call add1 3 times with the same input, we will get different values. It's not deterministic. And the third function, here by coffee, we expect to have a cup of coffee. But inside this function, it will pay the coffee besides returning the expected result. It's quite dangerous. Here is a side effect. And it's like, we can even break the cup of coffee before return it. So we can never trust a non-pure function. So we need to make those non-pure functions to pure functions. So now parseInt will return an option of int, which makes sense if we have a value which contains no numeric value, we will get none. And if we have an integer or a string which contains only numeric numbers, so we will get our integer. And for add1, every time when we call add1 with the same input, we will get the same result, which now add1 is deterministic. And by coffee, if we need to have a cup of coffee, and then we will pay it, so we can be clear and we can describe in our output those types. This function will return a cup of coffee and we return the price of this coffee. So pure function, we can trust pure function. We will get what we expect. So pure function is total and free of side effects. Now we talked about effectful program and pure functions. Now we will have pure functions and which uses effectful program. No, we will have effectful program using purely functional way. So we are ready to cover some data structure built on ZIO. The main data structure is I/O. I/O EA. I/O is an immutable data structure that describes an effective program that might fail with a value of type E, run forever, or produce a single value of type A. So an I/O of EA describes an effectful program which can fail with a value of type E, like parse int of hello, or computes a value of type A. For example, parse int 1 will compute a value of type int. And I/O of nothing A will never fail. Like println hello will never fail. It will return an I/O of nothing, and it will compute a value of which type? Println will return unit. And for an I/O E nothing describes an effect which never computes a value, like throwing an exception. I/O nothing describes an effectful program that never fails nor computes a value, like while true, without doing nothing. So the I/O structure, it has map and flat map to be able to use for syntax, and in order to create a value of type I/O, you can check the companion object I/O, which every function will describe a different type of effectful program. And for example, in order to describe a pure value, you can use I/O now, and also there is I/O point, and which will never fail. And in order to describe synchronous effect, you can use sync if your effect will never fail, and if your effectful program will fail with throwable, you can use sync throwable. If your program will fail with exception, you can use sync exception. And if you want to control which the type of error that you want to get, you can use sync catch. And in this case here, our error type is string. You can describe asynchronous effect using I/O async, and for concurrent effects, you can describe your I/O value and fork it. And when you fork an I/O value, it will be executed concurrently with the main program. So if you fork a value in other fiber, and then you can join it and to get the value of this fiber. And also, if you have, for example, an I/O value which runs forever, you can interrupt it. And also, there is you can observe the fiber, and check if the fiber is run successfully, or is failed with an error, or is interrupted. You can also describe resource effects using I/O bracket. Instead of calling try finally, you can put the acquire function and then the released function, and after that you can do your computation using the acquire function here, like open file. So it's very important to understand the type I/O, because every type built in ZIO will return an I/O. So like Q, every function in Q will provide an I/O value. And when you define a value of type I/O, it is only a description of a program, but it will not run right away. Only if you call unsafe run, you will run the program inside the I/O, and you can also extend ZIO app, and it provides this functionality automatically. So it's like you describe your program safely with purely functional way, and then when you want to run your program, you call unsafe run. And here is another data structure built on ZIO, which called ref. Ref has a value of type atomic reference, which describes like we have a var, we can update or modify this value, and atomically, which means if we have concurrent states, we can use ref, and we can avoid what is called. We can avoid. I forget. We can avoid what? If we have a concurrent program and we modify race condition. Okay, race conditions. Yeah. So ref has get and set, update and modify functions. You can for update, you can have the old state and you can update it, and modify here is more powerful. You can do your computation using the old state, and also at the same time you can modify it. So here modify is powerful because it will avoid race conditions. You can at the same time you can do your computation and have the previous state and update it. And in order to create a value of type ref, you can call apply inside the companion object with a given value. So here is a simple example. For example, you have a ref of type int and you can increment it. So using update. Or for example, if you want to update the integer, the 0, and also you want to print line the previous value and the next new value, so you can use modify. So as I said, this type, you can use this type if you have concurrent state. And here is another data structure built on ZIO, which is called promise. It is an asynchronous variable, like ref. A ref is a variable, but promise is asynchronous variable. And also you can set a promise only once. Which means if you, promise of EA, it can fail. if you complete your promise with an error of type E, and it can succeed if you complete the promise with a value A, and once you set your promise, you will have this, the specified result, and you cannot complete twice the promise. It will only have the first value that you completed with. For example, if a promise will be failed with an error, you cannot after that complete it with a value A. So by default, the state is pending until it's done, and it will be done if you fail it with an error or you complete it with a value of type A. So let's see, okay, the structure of promise here, and you can, in order to create a promise, you can call the function inside the companion object make. So, for example, you want to be kind, and you want to implement an alert for your friend's birthday. So you can make a promise, complete it with the reminder for the friend name birthday, and then you can delay this promise until the date of the birthday of your friend, and fork it, which means it will be this promise will be completed after some delay in other threads. That will not block our program. It will be run, and then we will get the message and send the alert in other fiber, and until the birthday of your friend, you will get the reminder notification. So here now we can build an asynchronous application using promise. So now let's cover the queue data structure. It is an asynchronous, non-blocking queue, which allows you to add and remove elements in FIFO manner. So you will have producers and consumers, and you will have a queue with a value of type A, and the basic functions in queue are offer and take. And the structure of queue is like this. You can also take all elements and offer all if you have many values that you want to offer. And in order to create, you can use those functions inside the companion object, but it depends which strategy you want to create the queue. In queue, queue in ZIO has two types: bounded queue with capacity and unbounded queue with no infinite capacity. So bounded queue has three strategies: back pressure, sliding, and dropping strategy. So in order to create a queue, you can choose what you want following your specification, what you want to do with queue. So and the queue in ZIO has the behavior of the consumer. The behavior of consumer will be the same behavior in all strategies and the queue type. It's like this. This strategy is back pressure. For example, we have an unbounded queue, we have concurrent consumers want to take values from the queue, and they will be suspended until a new value will be offered in the queue, and then they will take the values right away. So this is how the consumers in ZIO will work when you use any strategy of queue. And for bounded queue, it uses back pressure strategy. For example, we have a queue with capacity 3. There are 4 concurrent producers. They offer values to the queue, but this queue is limited, 3 elements. So the 4th producers will be suspended until a consumer come and take a value from the queue, and now the producer can offer the value to the queue, and the producer will be happy. If you want to create a queue, sliding queue, you can use the function sliding with capacity 3, for example, here. When you offer 3 values to the queue and you want to offer 4th value, the oldest value in the queue will be deleted and the 4th value will be added. This is the sliding strategy. And for drop-in strategy with, for example, 3 elements, if you want to add another element and you will exceed the capacity of the queue is full, so the new value will be deleted. So, for example, for back pressure strategy, we can think about it can solve different problems. For example, for an elevator system, you can use bounded queue for the request. If someone is in the floor 1 and the other 2, 3, and you have, for example, 3 elevators, you can have a queue with capacity 3, and if there is another request, this request will be suspended until an elevator will be free. So you can use this strategy in this case. And for sliding queue, you can use, for example, if you want to build a chat application with a free chat application with limited messages, and if someone wants to see their history, they need to pay, so there will be always the new messages and the old messages will be disappear. And for drop-in queue, for example, if you want to build an application that, for example, you can order only three products, so you can limit this with drop-in queue. And if someone wants to add a 4th element, it will be deleted. It will not be like back pressure suspended and then back, so you will be safe. And for example, if we have an unbounded queue and you offer forever values and take forever values, you can after that you can shut down a queue, and here the consumers and producers will be interrupted, and the queue will be empty and everything will be removed. So shut down, you can use it. And this is all about queue. And it's really, those data structure, ref, promise, queue, are really enough to build asynchronous and concurrent applications. And personally, I got a new job thanks to ZIO, thanks to what I talked about, I solved a problem of elevator system using ZIO, and you can find the project Scalaz-ZIO here, and you can also see examples or and the documentation in those links, and if you have questions you can chat in the Gitter room. And thank you all for coming, and here is, you can follow me in Twitter and GitHub. Thanks Milano Scala Group. Thank you all.
Ci sono domande? There is any question?
Did you understand?
So you said you're using Scalaz-ZIO in your work. I mean,
No.
or not?
I learned. I didn't use it. I didn't use Scala-Z before because in my work they didn't use it. But I learned that from my contribution, and it's really powerful. And with just some lines of code, you can do you can solve real world problems. So it's really interesting to learn that, and also the contributors of Scalaz-ZIO are they help each other, and you can easily have answers of your questions. Yeah.
Have you used the FSTU queues or Monix queues?
No.
Oh, okay.
And
Because they're pretty, they're similar in many aspects.
yeah, but I think Monix queue, they didn't have those strategies, or I have no idea.
Monix is a bit different, but the FS2, for example, has this kind of queues, bounded, unbounded, circular buffers.
Yeah, but as I know, ZIO Queue is really high performance. You can use it. Yeah, actually the first implementation wasn't really high performance, but there are some amazing contributors that changed the implementation, and it's really high performance now.
Other questions?
Sorry, but the slide where there were people in queue,
Yeah.
such a good order, it was not in Italy.
Oh, that's probably UK. People love this in UK.
We don't queue.
Because they wait until.
In Italy, never.
You have a lot of race. You have a lot of race conditions.
A more serious question. The method take all.
Yeah.
Can you take this?
Yeah.
What does it do?
It will take only the element in the queue. If there is no element, it will not be suspended. It will take the elements.
All the elements?
Yeah, in the queue, inside the queue.
All the elements?
Yeah.
So why the type is A?
This way. Thank you.
Well,
It
take
was
up
a
to two.
Yeah, up to. Yeah, I
Take up
didn't.
to, yeah, both.
Thank
Okay,
you.
yeah, you're welcome.
Is there any other question?
Are you still contributing, or you finished your contribution to Scala-ZIO? You're still contributing?
Yeah.
What are you still on the queue or something else?
Sometimes, for example, they added a new data structure called ref-n.
Okay.
Sometimes when I see a function that we can add a function, I add. And sometimes I add test or something to. By the way, I started contributing in ZIO I wanted to understand it, so I started implementing tests for promise and ref, and all of this used I/O, so I should understand I/O. I understood I/O, so then yeah.
Good.
And there are many other data structures built on ZIO.
So what's the version now? Current version for Scalaz-ZIO? What is it?
I think 0.6 or something.
Is there any plan? You know what's missing for a final release?
I think some fixes. I think normally it will. I have no idea. I thought that in December there would be the version 1 of ZIO, but no idea about this.
Okay.
And no, don't forget there is also a type stream type in ZIO that it was from November. They revealed this type. It's interesting.
Do you know if ZIO has the type class instances for cats effects? Like
No,
concurrent
it's-
effect, concurrent effect?
Sorry?
Do you know if it has the type class instances for the cats
No,
ecosystem?
ZIO, it's with zero dependencies.
Yeah, but there is a package like Intero.
Yeah. It's about if you want, for example, you are using cats and you want to use the functionality of I/O of ZIO, you can use those functions in Intero to switch
but
from cats to
If I
ZIO.
remember correctly, there was like missing concurrent or effect. I don't remember.
Sorry?
The-
Yeah.
Like concurrent was missing or effect. I don't remember which one. Is it their plan to add this type class in 1.0 version?
I think there was a discussion, but
Yeah,
I didn't follow it. Yeah,
Okay.
I have no idea which.
Yeah, there's a long discussion,
Yeah.
but
Yeah.
I don't remember how it ended.
yeah. No, it's still. I read it through during the Christmas holidays.
Okay. Thank you very much.